Let's turn that way down. Uh, Based on the past, I think that that might work. Um, I'm just rebuilding Raspberry Pis. Uh, this room is a mess. I've got a lot of computers. I've got a lot of cords. There are hundreds of devices in this house. So what I'm doing right now is just rebuilding things. Just wipe them clean, start over. Uh, if it's not saved, it wasn't worth it. So that's what we're doing. So I'm looking at a post that I made in December, kind of following the same thing because I'm going to use Ubuntu for a bunch of this stuff. And yeah, that's where I'm at. So follow along or not. It's Friday. It's Friday night, and I'm this kind of geek. This is my Friday night fun. So what I've done so far is this, and I think that was the last thing I did. Yep, I just installed the extras. So now we're going to do this. So you can follow along. And I ask your questions. I'm here, but this is more kind of like a co-work thing. I'm just doing stuff. Just doing stuff. I'm gonna get Kubernetes on all of this infrastructure, on the new, on the old. I'm comfortable running it on Raspberry Pi devices, and it doesn't get much smaller than that. Even though I do have some RISC-V devices that we're going to deploy, but I also have some x86. I'm basically just going to try to get everything deployed, get a Kubernetes dial tone, get some Kubernetes context configured, and that's the goal. I'd like to do that this weekend because next week I'm going to be doing a lot of Spring land on Kubernetes and talk about like, hey, here's the deltas. I have a project that's kind of been sitting on the back burner, but it's cool that I've just take Spring to Kubernetes, talk about the differences, show the differences, maybe learn some stuff. It's always good to kind of like flex those muscles, and that's the plan. So yeah, nothing. There's not going to be anything fancy or special during this stream. There never is. But what I am going to do is I'll do it live, and maybe we can have a conversation. But that's all I'm doing. We're repaving the home lab. Repaving the home lab. Just building stuff. There's a bunch of kids here tonight, so I guarantee there's going to be interruptions. But it is what it is. Hopefully the music isn't too loud, and hopefully the audio is good. I know that this has been it's a work in progress. I'm getting better, I think, at this. I'm definitely comfortable. So let's see if we can get something done. The nice thing is I've kind of taken good notes. So yeah, I'm upgrading. So this my build that I'm doing now isn't using 22.10. It's using 23.04. So maybe a good idea would be to take some notes on what we're doing. I don't think I need that up. I'll come back to that. I will come back to that. But let me get some notes. New tab. Let's do one of these. So the one change using Ubuntu 20.04. Yeah, same steps. Sudo apt update. I didn't do anything else. I did the advanced install for my username and my SSH credentials. I did the sudo apt update. I did sudo apt install Linux modules extra raspi, and then where the step we're on is sudo apt dist upgrade -y. One of the cool things I learned earlier this week is that when you do a do release upgrade in Ubuntu, it actually sets up another SSH port in case something goes wrong with the install. You have your SSH server on another port that you can always go back and get into that remote node and fix it. So after this one, what I have is I have a cluster hat. So it's a Raspberry Pi 4 on the bottom, and then 4 Raspberry Pi 02Ws on the top. So it ends up being kind of a mini cluster, and I turn it into a control node. We're going to use K3S, a control node here, and then 4 little 512 megabyte worker nodes. When I did this in the past, this is where Deshaun.dev was living for a long time. One of the things that I ran into, I'm using SSDs. I do have some instructions on how to do this with iSCSI and use like a QNAP, but I'm going to use the SSDs today because I want to get these done. I'd rather be up and running than have everything perfect. So let's just get everything up and running. I heard some fuzz in my headphones. I'm wondering if you guys are hearing the same thing, because that's frustrating when it's just me. Why is there fuzz? But yeah, one of the things that I ran into is problems with the disks filling up, so I'm going to try to avoid that. But I have like 6 or 7 of these little clusters that I'm going to put together over the weekend. So I've got this one is going to be a single node. The one that I'm working on right now is a single node cluster. This is a 5 node cluster, but it'll still be like a single unit box. And then I've got some other, it's a 2 node, both 8 GB Raspberry Pi 4s. And these are going to be power over Ethernet. So it doesn't really mean anything to the workloads, but it's going to be something different in the way that we deploy it. We're going to deploy these in different parts of the house, and we're going to have different sensors and pieces of hardware attached to them. And we're going to talk about how to get those different workloads. How do they find where they're supposed to be? If I have a what's a good sensor? If I got an LED light, I should have one of these sitting around here somewhere, like this. If I have one of these nodes that has a sensor on it, I'm going to label that node, and that node's going to say, hey, I've got this sensor. Then the workloads are going to be assigned a affinity. You know, if the workload needs a sensor, the workload will have that affinity to a node that has the sensor that it needs. That's it. That's it. So we're going to do some mixed operating system, mixed architecture clusters, things we've done in the past. So I'll have ARM64 nodes deployed with x86 nodes in the same Kubernetes cluster, and we'll run into some interesting use cases there. But yeah, we're gonna do stuff, and I don't like the way that this buzz keeps coming in. If you're hearing it, let me know. I hope it's just on my side. What do we want to do here? Which services should be restarted? Yeah, that's fine. Restart services. Yeah, just restart them all. Cool. All right, next step. Let's do this. We're editing this command line, and these steps I've documented it many times before, but this is so that we can do C group. It's not enabled by default, but I should check, because this was necessary in older versions. How do I check if that's still necessary? Is C group, or going to check if C group enabled. How do I check C groups are enabled on Linux host? I don't know these things off the top of my head. systemctl. Let's do this first. Here, systemctl pipe grep -e cp manager -ecg proxy -ec group fs -mount. Or as user mover suggests in the comment, systemctl status. Oh, that's a whole lot easier. Systemctl status cg. Nothing. Cool. So I do need to still do this. And per my notes, all I need to do is add this to the beginning. Oh, that's not what I wanted to do. Copy, boop. And we're going to boop it. There we go. Space, 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 Control X. And now, sudo shut down now. All right, so that box, again, it's an SSD. Running it, we'll let it reboot. And then when we come up, we'll install K3S, and we're going to use K3sup again. So while that's rebooting, let's do which K3sup. All right, cool. Let's take a look and see if there's a newer version. Can I do K3sup -version? K3sup version, K3sup version 0.12.12. Let's do K3sup update. And it says, I think I have arcade, right? Which arcade? I don't. That's silly. Why don't I have arcade installed? You can update with the following. Do that. Remove this for Linux Macs. Let's just do this. CB, boom. Whoops. I didn't like that. Curl -slfs get.k3sup.dev pipe sh. I've done it enough. I'm feeling pretty lucky. So, wait, did I even type that right? I didn't. Because I was looking at this one, but I should have been looking at this one. Sudo. Okay. So what does it say? I did it. It says downloading the package. Download complete. Running with sufficient permissions to attempt to move it to there. New version installed. Bootstrap. Yep. K3sup needs your support. I love this product, and it was the same version, so we're good. All right, so our other box should be back up now. So let's SSH to that box. It's not up yet. I'm looking to see if there's any lights going. There it is. Cool. So now we have all the latest and greatest, but we don't need to be on that box. So just kidding. What we're going to do now is we're going to give it that node. Export control node IP 10.14.122, 10.14.1.22. Okay, and then we are going to K3sup install IP $control node user. Well, I did that wrong. The user is Deshaun. K3s-extra args. I said disable traffic. So I haven't used K3s. I haven't done an install in a while, and there's been a couple releases since last time I did this. So yeah, let's fingers crossed. We'll see. I did the extra args merge to local path my kube config. I want to bring that kubectl config, I want to bring it into the one that I already have locally. And I'm going to call this context single K3S. What did I do? It says invalid argument user for dash dash I. What? Invalid argument dash dash user. Echo dollar control node. Oh, I did control node and I missed the control node IP is what it should have been. So let's just go like this, control A, IP control node IP. There we go. So now my local box is reaching out to that single node Raspberry Pi, and it's doing the install. Things look good. So we're doing this step. I'm going to go ahead and take my notes here. I did export control node IP equals 10.14.1.22. And then I did K3 sup. I did the exact same thing, except my user was Deshaun. And my cluster name was single K3S. And user is Deshaun. For those of you that don't know, my name is Deshaun. And here we go. So, hey, it looks good. So now I should be able to do right here. It says, hey, do these things, but it's in mine. So I should say cube CTX, and I should see that in my list. There's my cluster. So let's go ahead and use that cube CTX, switch to that kubectl context, single K3S, and then I can do the kubectl get node dash O wide. Cool, and it's up and ready. So it is my control plane node, my master node. Cool, it's been up for 53 seconds. So here's my Kubernetes version. There's my IP. It does not have an external IP, but it does recognize the OS image. So that's good. So let me just take a copy of this for my notes. Cool. And I'm gonna do it like this. Boop. I'll boop it. Alrighty. So we've done that. We're not going to add any other nodes to this cluster. So deep breath. This is where I struggled how to deliver this. I said that I just wanted to get Kubernetes up and running. I don't know if I can get Knative running on a single node 8 GB. I can do it on, I know I can do it on 16, but I don't know if I did it on a 16 node or 16 gigabyte laptop, but I don't know if I've ever done it with 8 gigs. Is it worth going down the rabbit hole, or should I just leave it here and move on to the next one? Because I can always come back and install this stuff later, right? So this is all, I've got a Kubernetes dial tone. That's what I said I wanted. So let's just stop there. I can always come back and add Knative. I don't have to go down the rabbit hole in this. I have a Kubernetes dial tone. That's what we want. So let's stop here. Let's call this one good. And let's make a note of mission. So we have single K3S. That's the one that we've done tonight. So now what we're going to do is we're going to move on. So that guy's deployed. That node is deployed. So let's do our next cluster. I said I was going to do this one next. So let's do this one next. So this is the cluster hat. So let's go to those instructions and again, luckily I've got the cluster hat instructions here somewhere. Let's boop it. Here we go. K3S. This is from last July, so maybe we'll have some updates. Oh, it was updated April 29th. I don't know. I don't remember doing that update, but all right. We're going to deploy K3S to Raspberry Pi cluster, cluster hat, cluster control. Boom. We got this. This is the exact same setup. This is the exact same unit that's in that blog post right there, right? And I see the disks. Okay, so I got all the SD cards. So because you are using cluster hat, you will want to use custom OS images. So there's a link to my images. So let's see. These images, please tell me, I don't remember. I think I did the pass through, the bridge. I think I was doing the bridge. For this guide, you'll be using the 64-bit version of the each and the CNAT Lite version for the controller. Enable SSH for each of the images. The username does not have to be Pi, but the username needs to be the same across each of the nodes for the guide. As you burn each of the SD cards, place each one into their respective device to keep them organized. The P1 node is the slot that's on the same side as the Ethernet controller. So I've got the Ethernet controller here. So what I'm telling myself in this note is that this is P1 on this side, 2, P3, P4 as we go across. All right, so let's do this. Let's grab the host. So I'm going to take out this from the bottom. I'm taking out this guy. Boop, boop. That's the host node. As you burn the P1 node, the nodes increase in order. You can refer to an earlier post for detailed steps using the RPi imager. Let's look at this earlier post. So I had detailed steps. Okay, I did it with the 2W. Bring native edge RPi. Oh, that just shows me how to use RPi imager. Okay, so I'm going to do that. I already have RPi imager, but I got to download the OS images. So I'm going to do the CNAT Lite versions. So CNAT Lite controller is the light bullseye image for the controller. And this hasn't been updated, so I might already have this. I'm looking down at the bottom of the screen where I can see the, let's do it like this. Down here, it shows the dates of that. So this CNAT Lite controller, it's got a date of April 4th, 2022. So I think, yeah, those are all April. So I'm pretty sure I've probably got the latest versions. So let me just take a peek. See if I got those sitting somewhere. Downloads. What was the name of it? It would be 20 something that starts with 2022. And they're already sitting there. Okay, so we're just gonna follow the same steps. Let me make sure I got the right versions. I got the ARM64 Lite CNAT zip. Hello, let's make sure that's what that says. ARM64 Lite CNAT zip. Okay, so we're gonna do the controller one first. So let's get that started. It would be awesome if I had all this on camera, but I don't. All right, so I got a new disk. And we're gonna burn that guy using the RPi imager. Applications. Raspberry Pi imager. We're gonna choose our OS, and we've got custom. So my downloads here. This guy. That's my controller. We're gonna do it on this one. We're gonna put in some extra stuff. So what are we gonna call this? Did I have any naming conventions? I did a control node. I mean, that kind of works. I'm gonna call it cluster hat 00. Cluster hat 00. Because I've got multiple setups like this, we're going to do this, and then we'll call them cluster hat 00 P1, right, for the others. So we're going to enable SSH. I got a key. Yep. And we're going for a default password. Should I do that? Or should I just, no, I don't need that. Yeah, I will leave that. I'm not going to configure the LAN. I am going to configure the locale. And I think that's it. All right. And then I can write. So that'll take a sec. That's the right one. All right. So we're installing the cluster's control node. What I'd like to do is get it up and running while I'm burning the other one. So I think I just need power. Let's see if I can get some power going over here. Let's see if I can get some Raspberry Pi power. Please hold. Power. How do you plug it in? Let me show you a little better. Oh, I did the power, and now I realize I gotta, if I want to do this right, I want to get the network as well. Let me turn this off. So that when I plug, I think I have a network cable usable. And yeah, the office is a mess. And that's why we just want to get all this stuff deployed. If we can just get everything in a spot, get a Kubernetes dial tone, then I can get rid of all the extra stuff. I definitely have a lot of extra stuff here. But let's get a network cable. Let's see what we got here. This Cat 5. It really doesn't matter for the Raspberry Pi, and I can't tell on this cord. Let's see if we can get some networking. I have a switch over here. I know I got one. We'll do it this way. Sorry about that. Unplugged a different cluster. Let's get the Ethernet in. All right, it looks like our control node is ready. So let's get that out. Take the control node disk out of the oven. And let's do these one at a time, sort of. So we'll put this one back in. I'm going to take the other disks out from all the other machines. So they don't have a disk and they shouldn't be being controlled anyways. And what I'm going to do is I'm going to just make sure that I can get to this box. So I'm just turning it on. Hopefully it'll come up. And while that's working, while that's coming up, I'm going to take P1. I'm going to do P1. And we'll put P1 into the oven. So I'm getting the disk for P1. Keep me straight if you can. We're going to change to the custom 2022 P1. Okay, the storage this time, it's a smaller disk. We're going to set these configs to be the exact same, except this time it's cluster at 00 P1. And everything else will stay the same. And we'll write that. Cool, so that's writing. And the disk is still spinning on the other. So let's do this. Let's ping, or let me see if I can get the IP address. I'm going to go peek at my router and see if it's assigned an IP address to this yet. I said it was cluster hat 00. It's not showing up yet. It should be showing up, but it's still coming up. So that SD card that we installed, it unzips it and it's going to reformat the disk a little bit and give itself some space. So that'll take a second. I will keep on watching the screen to see if maybe it comes up. But at the end of the weekend, right now I've got, it's weird, I got 48 devices that are on the network. By the end of the weekend, we should be close to 200 devices on the network with all the Raspberry Pis. So we'll see here. Still trying to see if I get an IP address for cluster hat 00. And disk is still going. I'm not setting up a screen. I'm really just looking at the disk. I told it, or we configured it to install SSH and give me an SSH user to access it. And if that doesn't work, then out of luck. So we're just waiting for it to boot up. Oh, and there it is. So this one is done. I'm not going to do that. I'm going to do this first. I'm going to go, I know the IP address here. I'm going to SSH 10.99.1.112 and don't look.
What are you doing?
I'm deploying all the computers.
Why?
Because I want to get rid of the mess. I want to deploy all the computers.
Call me a hoarder?
I'm going to get rid of all the computers. I'm going to get rid of all the stuff. It's going to be deployed and they're all going to be put away and then we can get rid of all the extra stuff. I didn't, maybe.
Not in my area.
Ignore her.
Can you go upstairs with the girls? So I run over to
Just have them come downstairs. All right. And close the door.
that defeats the whole purpose.
No, they'll be where I can hear them. Okay. All right. I told you. I told you. All right. So we're here. What? Oh. Wait. Now this is a problem because it should have installed the SSH key and it doesn't look like it did. But that's okay. So we'll get through it. Hi, but I'm on the show. You guys sit out there still. And here we go. That's not going to work for me. Oh boy. Hold on. All right. So that's there. I said connect the control node, power it on. So that I kind of skipped some steps. I can connect to the control node. I'm not going to power on P1 because I haven't installed it yet. So let's grab P1. We're going to take P1 out of the oven. Okay, P1's coming out of the oven, and I can plug it in. So P1 is installed. Now I can do this. I can do cluster CTRL on P1, and I expect to see a light go on, and it did. All right, so now that's booting up, and while that's booting up, let's get another disk and let's put in P2. We're gonna put P2 into the oven. Okay, we've got a disk for P2. We're gonna go choose the P2 image. Hold on. All right, P2 is set. We're going to put it on. This one's got a 32 gig, so I didn't really do a good job of keeping things similar. But all the things are going to be the same, except this one's going to be P2. So let's save that, and let's bake the OS image for P2. So with that going, P1 I can see is still coming up for the first time, just based on the lights. You'll see the green LED light up and the node will begin booting up. Well, was it green? No, I got an orange one. And it's orange in the picture, right? It's not this light. It's the one on the other side of it. That's the power light, but there's another one. What green light was I talking about? Oh, there it is. Wait. I see a reflection. There it is. I see it. The green light is on the Raspberry Pi Zero. See, I'm kind of being lame. It'd be nice if I could show you what's happening, but I apologize. This is a lame stream. But what we've done so far is we have a cluster. We got the single K3S cluster stood up. This one's going to be K3S because I know that works. But on this other one, I think I might do microkates from Ubuntu. The idea is that Kubernetes is just an abstraction and there's different implementations. I'm going to have multiple, at the end of the week, I'll have multiple flavors of Kubernetes running. And we'll just do a little bit of comparison. Not everybody's going to use K3S. Not everybody's going to use Docker. So that's one of the others. I have here. I can show that. Let me here. My Cube CTX. You'll see that there's a Docker desktop. That's the machine that I'm on, my Mac Studio. But yeah, like Kubernetes is Kubernetes, and we'll see kind of where that changes, what parts aren't the same. Let's go back here. You know what I can do while that's coming up? I can do, what's the SSH copy ID or something like that? SSH copy ID. Blah, 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 blah. SSH copy ID, right? SSH copy, SSH dash copy dash ID. Which one? This one. To Deshaun at 10.99.1.112. So then I shouldn't have a password. Cool. So we're back to here. I realize that might be a little bit hard to read. All right, let's go back and let's see. P2, we can take P2 out of the oven and get it deployed. And P1 is green, solid green. We're deploying P2. And I will go back, and just like I did on P1, I'm doing on P2, and I see the lights are good, and now I'll cook P3. Let's put P3 into the oven. These are the host operating system images that we're doing. So it has nothing to do with Kubernetes, but it does have, these are custom operating system images for this cluster hat. So this cluster hat can treat those daughter boards or child boards or whatever you want to call them, treat those as part of its system. So let's get P3 baking. Choose, change the name, save and write. Okay, so we've got 2 out of the 4 child nodes running, and we'll continue working. So while P3 is baking, P2 is on, and I could do this. I could do this. So let's do that. Let's do sudo apt update on the control node. So what I'm realizing is I won't be able to run Knative serving. Oh wait, can I? I think it was the problem with Envoy. So since this is built off of Bullseye, and I know that the Raspberry Pi, there was an issue with the kernel to where I couldn't do it. I had to use Ubuntu in order to deploy Knative serving. So that's okay. So this will just be a difference of the clusters, and that's all right for me. So now we've got some stuff. Let's do the sudo apt dist upgrade. So this is just the control node. Go do your stuff. So that control node is updating. The P3 is baking, and P2 is now solid green. So that's good. I'm pretty sure that these IPs are defined. So I think I can use those IPs. Yeah, because they're natted. So I think I can do those exact same values. So this is P3 is done baking. Let's grab P3 out of the oven. Put P3 in. Okay, P3 is in. We're doing the update, so we don't need to worry about it. But we can also fire off, put P4 in the oven. There's P4. Choose. Oh, I didn't put the disk in the oven. I don't want to do it on that drive. That would be bad. Okay, let's put P4s. This in the oven. Try that again. That's better. Let's modify it. This is P4. Save, and we're writing P4. So our control node is getting a distribution update. It's grabbing all the latest stuff. P1 and P2 are up and green. P3 hasn't been turned on yet because we're still upgrading the control node. So we got to turn on P3, and after the control node is done, we'll go and upgrade all of the P1, P2, P3, P4. So yeah, this is kind of boring stuff, but that's okay. This is how I rock on Friday. So since these are natted, those hosts aren't actually going to show up here at my router, which is good. That's cool. I think I'm doing this right. Or did I run into an issue? So I do have to do the same thing. So this doesn't need to happen on the control node. Yeah, it does, because it's natted. So it's going to be on the same network. Yep. Okay. And then I think that'll work. So just peeking ahead here at what I did. Cool. I think this is right. All right, P4 is done baking. Now we can close the pie imager for a minute. We'll take P4 out of the oven. All right. And P3 and P4 are ready to go, but control node is going to take a little bit of time. These SSD cards are not fast for writing. So yeah, it's slow. The alternative that I've done in the past is I had the control node booted over iSCSI, and I updated the iSCSI image separately so that when this came up, we were good. The one thing I didn't get to do, the alternative to having these natted, is they can be bridged. So then they would show up at my router and they would be on the same network as all of my other stuff. But I found out I didn't need that. It made things noisy. So yeah, I switched to the CNAT. But there's something in the back of my mind that has me questioning if I did if I left it on CNAT or if I changed it later. I feel like for some reason, after I did that blog post, I went back and I changed it to bridge, but I don't know the answer. We'll find out together. So we're deploying a cluster. We're deploying this cluster hat. I think there's nothing that's jumping out from memory. So that's why we're taking notes. And I'm just hoping to get a cluster. So the one thing that I did here is I installed K3 sup on the control node, and I don't think I want to do that, but I might have to because the control node, I want to use this IP address, but I don't think I can. How can I access that NATed network from outside? I could like do these over SSH, but then I still have to install it on that box, right? I might have to do it this way, but I don't like that. Is there a way to do this? I should. I'm going to draw a picture here. P1. And these guys, they're getting these NATed IPs. Oops. And this one has, hello. Two, 5, 5, 4. So they can talk to each other on that same network, but I'm out here on the 10 dot, right? So I can get to this guy. He also has the 10.99.1.112 that we can see over here. So I can get to that from my computer, but I need these computers. I want Kubernetes. Is this 172 dot? And I want to keep it that way. I don't want this child of this control plane, or that control node. I don't want that guy talking over the 10 dot network for all of its Kubernetes API access. I want to keep it isolated to this network because there's no reason that it needs to talk outside of that network. So I think I was preparing myself here, but now then, how do I get how do I do kubectl? I don't want to have to go into this box to do the kubectl. I think I'm going to have to redo this already. My intuition was right. I'm not going to do CNAT. I'm going to do the C bridge. But the funny thing is I don't have the C bridge stuff downloaded. I only have the CNAT stuff downloaded. So why would I have done that? Thinking. We'll figure it out. What would be the benefit of doing the C bridge? Nah, unfortunately, I'm sorry. This boring, lame stream just got even more boring because I think I'm going to switch. Now, it looks like I don't have to redo the P1 to P4, but I do have to redo the bridge. So I'm going to rebake cluster hat 00. I'm going to rebake. So I'm going to turn it off. Turn everything off. I'm going to leave P1, P2, P3, and P4. I'm going to leave those images. They're up and running. They're fine. They don't care. They shouldn't care. But I took the disk out. This was a CNAT image. I'm going to download the bridge. Light. And I'm going to rebake the controller image. So lame stuff. I apologize for the runaround. Let's bring back our RPi imager. All we're doing is it's just like doing an install of an operating system. We're going to go do this custom. And we're doing the bridge. We're going to choose that disk. We're going to make some updates here. We called it cluster hat 00. We're enabling SSH. This didn't work. Oh, because I didn't hit this. That's why. We want this. We are going to set the local settings. Save. And we can write that. Sorry, it'll take a little bit. I really wish I knew why that fuzz was in my ear. So this is on that computer. Check, check, check. Fuzz, fuzz, fuzz. I don't know. We'll figure it out. We will figure it out. This is a little bit much. Let's turn it down. I'm going to close a couple of other windows on these other machines. And we're just taking time. And that's all that I should need. Fingers crossed. The CNAT versus the bridge, I think it'll be okay networking wise. The way that these cluster hats are set up is the cluster hat board gets connected to the control node over USB. So I believe it'll be just the networking part. It'll get managed that way. We'll see. Like, what could go wrong? We're building clusters. So while that's running, let me see if I got disks. Okay, I got 2 more disks here. The next cluster that we'll do is going to be a PoE cluster. And there's actually going to be 2 different PoE clusters on the same PoE switch. And they're both Raspberry Pi 4s, but they have different PoE hats installed on them. So that'll be interesting to compare. All right, so the cluster control node is baked. We're going to take it out of the oven. And we're going to have to repeat a couple of steps. So control node cluster hat 00 disk is going back in. I'm going to power on the cluster. I'm curious to see if it'll get the same IP address. I'm just going to move this over because we're going to do some others. But we're deploying Kubernetes. Let's get Kubernetes dial tones for a bunch of machines. What that's going to do, so it doesn't have any memory, so it doesn't know that it needs to turn on cluster P1, P2, etc. So we're letting the disk come up. I'm going to go check on the kids, and I'll be right back. All right. Thanks for waiting. Let's see what we got here. It looks like I have the same IP address. So let's SSH to that box. It says, hey, I don't remember that. Wait, I thought I fixed that. Let me maybe not do it on this one. I'm going to open up another window. I thought that I had set my SSH config to ignore that kind of stuff. .sh config. Nano. That didn't work out the way I wanted. Identity file. I thought. Here we go. Can I do this stuff? Copy. I can do this on screen, right? I don't care. So I it's this right here. I think I can do this for no. I think I can do this. Oh, we're just gonna do this. Hello. Do that. Okay, cool. All right. Now what we're gonna do is go back to our instructions. And what do we say? Cool, we did it. We did it. Let's see if we can cluster CTRL on P1. Okay, P1 is on. P2, P3, P4. Okay, all the lights are on. Now, all of those disks are going to come up and boot. And while that's happening, we are going to go to these next steps. And we're going to say sudo apt update and sudo apt dist upgrade -y. Again, we're just repeating the same things. All right. I think I can do this. I don't want to do that. All right, so that's going. Nothing fancy here. We're not doing a whole lot. My instructions are going to change a little bit. Let's go do this. Cluster hat 00 using bridge instead of NAT. Most will get new IPs for P1 to P4 because it's a bridge, so they'll all get their 10.IP. So yeah, I won't get to do the less noisy, but what I'll do is I'll put them all in the same switch and hopefully we can isolate a little bit. Make sure to keep these clusters on the same switch. Because it's all in the same, within the same device, that shouldn't be too much noise, but still, we'll figure it out. The main goal is to have kubectl, kubecontext for all these different clusters. But why? Why, Deshaun? Why have a bunch of clusters? It seems like it's more to manage, but it's actually going to be easier to manage. I can upgrade clusters. If something goes wrong, my blast radius will be smaller. Plus, I want to be able to do the experiment on different types of clusters and do the compare and contrast. And if I mess up a cluster, I only mess up 5 computers instead of 105. So this is going to be slow. This is the absolute most boring stream that you could possibly watch. You shouldn't be watching this because, yeah, it's boring. I wouldn't watch it. Well, maybe I would. Like Rob, RWX Rob. I enjoy because he's good at thinking out loud. I'm not as good at thinking out loud. I try, but we're working on it. Friday night, this is how I roll. And it's not just Friday night. This is kind of how I roll regularly. But I've got this backlog of, I got a bunch of computers and I got a mess I'm trying to clean up. I'm going to get rid of some equipment. I'm going to take some equipment over to the church, but I just want to get all of these things deployed. And you know what else? I think I'm going to take that Spring Cubed node. Oops, I think I'm going to take that. I think I'm going to add that to one of these other clusters. Because a 2 gigabyte node, it'll work, but I think I might just add it to one of these other clusters. So let's do a quick little inventory. We'll have cluster hat 00. We'll have cluster hat 01, and these are the different contexts. All right, so this is single K3S. We'll have cluster hat 00, cluster hat 01. I don't know what that is. We'll have PoE 00. PoE 01. Oh, then we'll have the we'll have a 10 node B plus, which is the Raspberry Pi B3 plus. What other nodes we'll have? So one of those. So let's make this one. That would have to be the same, but this one, we can make this cluster micro Kates. What's another Raspberry Pi cluster? Kubernetes on Raspberry Pi. Kubernetes on Raspberry Pi. Micro Kates. This will be K3S. So this one, K3S. That one's K3S. K3S. Micro Kates. Oh, I know. Can I do open microshift, or what is it? Can I do microshift? Microshift Raspberry Pi. OpenShift and Raspberry Pi 4 tags. Yes. Microshift Red Hat emergent. Okay. Microshift, where do I get it? So that's what we're working with. What makes field deploy devices different? That's what we're talking about. Blah, blah, blah. Oh, you know what else? Let's go here. Okay, microshift. So that's what this is going to be. Microshift. I have the B plus cluster. That is going to be, so this is, these are going to be the same because they have to use a cluster hat. This is with Ubuntu. This is, will I install? Show me a quick start with Raspberry Pi. Oh, that was weird. If you not have a rel, you can get a no-cost Red Hat developer subscription. That's what we need to do. So we're going to do Microshift on Red Hat developer subscription. The B plus, we're going to do Ubuntu. Can I do Ubuntu on that? I think we're going to try it with Ubuntu and K3S. Is there another flavor that I wanted to do on Raspberry Pi? I have K3S, MicroK8s, Microshift. I feel like there's another flavor. Oh, there's another cluster. I have the Turning Pi, which is, it's got a compute node. So I don't know, question mark, what that will be. But I think there's a few other Raspberry Pi devices that we'll just add to these other clusters. So that's a handful of clusters. 1, 2, 3, 4, 5, 6, 7 different Raspberry Pi based Kubernetes clusters. Well, that's the goal. I haven't even installed this. It's not even out of the box. So that will probably take some time to get up and running and figured out. But the rest of these, this is the goal. Let's get these others. I don't know where this one is. But we should be able to get this one, 4, 5. We should be able to get 5 clusters done tonight. All right, so let's go back. Let's see how we're doing. This is up. Keep the local what? Yeah. SSHD config. Let's keep the local version. Who knows what that does? But I can connect right now. I was really hoping that was further along, but that's okay. How come it didn't ask me that last time? Oh, bridge versus NAT. So slight differences. So just to recap, we did a single node of K3S running on Ubuntu. We got that up. We have our kube context. Cool. That's the box that we're trying to check, is just get kube control dial tone, Kubernetes dial tone on as many of these computers as possible. Tonight, we're going to focus on the Raspberry Pis, as many of the Raspberry Pis as we can find and box. Oh man, we got a bunch of stuff though, because we have, like, this is our Raspberry Pi setup. We have some what are those called? The Atom. We have NVIDIA, Jetson. We're definitely going to do the Nooks, right? So we're going to do a Nook 1. We're going to do Open SUSE, and we're going to run Rancher. We're going to do Nook 2. What other ones did I want to do? I definitely have to do Tap, and I think I'll do TAS on different clusters. Do I want to do it that way? Because I could do Tap on anything. I could do TAS on anything, so it doesn't have to be TKG. It might be fun to do like a Tap on OpenShift and like a TAS on vanilla. But I think that's the nodes that will get deployed. And yeah, we're going to get there. All right, so this is cluster hat. The control node is updated. What we did was we upgraded, do the updates, upgrade all the things. And now we're going to go back to our docs. And everybody's on. Everybody's up and running. But I don't know their IP addresses. So I have to go and find their IP addresses. So that should show up in my router because this is bridged, meaning even the devices, let's go look at the picture. Even these little devices that are sitting on top of the control node, they are going to get 10 IP addresses. So they should show up, and they do. They show up over here. So I'm going to kind of follow these same steps here. I'm going to add these to the control nodes Etsy host, but I don't really need to. Yeah, I don't need to. What I'm going to do here is from the control node, I'm going to say SSH 10.99.1.70. Oh, I got to get my, let's just see. So SSH 10.99.1.70. Yes. Okay, that worked. And then I want to do, sudo apt update and sudo apt dist upgrade -y. But I don't need to do that from here, because watch, I can do that. I can have those all going at the same time. So I'm going to open a few shells, new tab. Let's do them in different colors. Let's do red sands. So this is, do this, SSH 10.99.1.70 and do sudo apt update and sudo apt dist upgrade. The same thing I did on the control plane node. Oh, nano known hosts line 30. All right, let's get rid of those. Boop boop. There we go. Yes. All right, so that's going. I'm going to do the same thing. I'm going to open another. This will be SSH 10.99.1.71. Do the same thing. Sudo apt update and sudo apt dist upgrade. Yes, please. Yes, do the thing. I'll open up another terminal. So these are all going at the same time. They're going to flood the network because they're all going through that same control plane node. But it'll get done and it'll be slightly more enjoyable to watch. I'm not kidding anybody. SSH 10.99.1.72. And the same thing, sudo apt upgrade and sudo apt dist. Oh, wait, this is sudo apt update, not upgrade. Update and sudo apt dist upgrade dash y. Boop. Pop it. Yes. Big boy. And then shell. Let's do one more tab of solid colors. And say SSH 10.99.1.73. Sudo apt update and sudo apt dist dash upgrade dash y. So all this is, I have to do this, or I want to do this because I have this custom OS image that was generated April of 2022. Big boy. So I'd like to, patch it the best that I can. So part of the repaving process is I don't want to leave stuff lying around. So that's another part of why we're doing this. We're repaving. What does that mean? I'm deleting all of the systems that were running on this network and starting over. So if there's any bad actors on any of those devices, if there's anything rogue, it's gone. Wiping it clean, the best that I can. If somebody got into one of the disks or one of the processors like we had back in the 2017, 2018 with Spectre and Meltdown, they were doing that. There were some hacks. And who knows, right? I can't say it's all gravy, but the best I can do is keep everything upgraded and clean as possible. And hopefully we'll keep things safe. So these guys are all downloading the world. But I'm just following the notes that I had before, making a little bit of change here. So we got new IPs, make sure to keep these clusters on the same switch. That really doesn't matter as much. Less noise. But we're just going to have a lot more devices on this network than we have before. So what else can I do? So while that's going, I could probably get started on this one, but this computer is PoE. So these next ones are going to be PoE. And for PoE 00, we're going to use Ubuntu and microcates. I've not installed microcates before, so let's figure that out together. But maybe I should use that other cluster instead. Let me go see if I can get a PoE switch and this other cluster. I'll be right back. So I've got a PoE switch, but I don't know where the power adapter is for it. But you know what? No, this isn't a PoE switch. I got an extra switch, but that one's not PoE. Let's put that one away. I got so much stuff. But we're going to get it all deployed. We're going to get everything out to where it should be. And let's see if we can find things. This is another Raspberry Pi power adapter. Okay. Ugh. Oh, there's another cluster. There's more Raspberry Pis that I have forgotten about. I just need to find. I need to find the power adapter for one of these guys. So I might have to. I don't know what this is. I got boxes of stuff and I don't know what's in them. Easy SMX wired. Game control. Oh, this is a controller. So I got to find the power. So this is the cluster we'll do next. So this cluster, again, it's got different PoE hats on it, but it also has these NVMe disk drives. So I'm going to make this one microcates in Ubuntu. And we'll start baking. So in order to bake this, I'm going to take the disks out. I got 3 disks. These are 16 gig disks. Wait, 16, 32, and 32. It'd be nice if they were the same, but not crucial. Because I can, once I get them installed, they can boot off the NVMe drives, and that can be their disk. So it's not really that big of a deal, right? So let's do this. Let's set this aside. I'm going to bake those. So I'm going to grab one of these disks, and we're going to, while these guys are still running, we are going to put another disk in the oven. So let's go grab other, oops, not Raspberry Pi, other Ubuntu server, not desktop server, 64-bit server. Gotta get the storage in sure. Let's grab our disk. We have a 16 gig disk. 16 gig disk. And let's put another one in the oven. Okay, disk. And let's choose our storage. That's the one. Let's do, what did we say that this was going to be? We're calling this PoE 00. So let's call this PoE 00 S0. That'll be the one on the bottom. Enable SSH, do those things. Yeah, same. Good. And let's bake. Right, I have the right disk installed. Right, I have the right one chosen. Right. So now that's baking. So over here, we're calling it PoE 00 S0, PoE 00 S1, 00 S2. That's going to be their cluster. All right. Are these all on the same subnets? Am I going to run out of IP addresses? This is very possible that I can run out of IP addresses. Well, we'll tackle that when we get there. All right, so these are going. Still going. Still go. Detected unsafe path transition. That's interesting. Did that come up anywhere else? It came up there. Oh, and there. Yeah. That's interesting. Let's see how that plays out. I don't know that I've ever paid attention to these updates on those child nodes. Please reboot the system when convenient. Oh, this one's done. And it didn't have any of the... Did it? Oh, it did. Okay, so let's do this. Oh, I'm not on the box. So I think I'm just going to close out of that. That was the update. It's done for P1. All right, you're done. P2, P3, P4. We'll let those guys continue. But one of the other notes that I had here is I still have to do the C group stuff. I feel like there's, for the other one that we did earlier, we did a little bit more, right? Sean.com. When we were doing, I think I was just following this. We did this. I did C group enable CPU set, C group memory, and C group enable memory. And here I didn't do the C group CPU set. I didn't do C group enable CPU set. Now, why did I do both C group enable CPU set and C group enable memory? I don't remember why. But that's what the whole point of having these notes around. Now, because I have a kubectl see, this is ARM64 version. Because I have that, I can deploy these guys. What's my latest version of Spring Pi native? I thought it was Spring Boot native Pi, but either way. I mean, it's still going, even though it was throwing out some detected unsafe transition stuff. Those are the kind of things you get when you deal with custom OS images, right? What could possibly go wrong? We got stuff. We have stuff cooking. I just want, the whole goal here is to get Kubernetes dial tone, different flavors of Kubernetes, different shapes and sizes of clusters. While that's cooking, let me see if I can find power. This says it needs 54 volts at 1.25 amps. 54 volts at 1.25 amps is what I'm looking for. Wish me luck. I'm here. I'll be around here. Oh boy. All right, where's this guy? Um, Ugh. That's all right. So I've got PoE switch. PoE. Now I have a PoE switch for this PoE, power over Ethernet cluster. So I found the adapter. Now I need Cat 6 cables to connect, which I think it already has them. So these should all be Cat 6. They should be Cat 6. Cat 6. Cat 6. Hello, hello. This one has no. All right, Cat 6. So these 3 machines are going to plug into this switch, and we're going to do the same kind of deal. All right, so over here, I see that things are wrapping up. So almost. Processing triggers. This one's done. So 4 actually finished before 2 and 3. So 4 is done. And these guys are still updating. And they might be because of different disk sizes. And that's okay. So we have a PoE image baking right now. So I'm not going to plug those in yet, but we have an image baking. I'm going to switch the network. So if I plug one network in there, I can plug this in here. So I'm going to get one more power. Actually, I'll move that guy back up into the closet on the last reboot. So this one's done. And this one's still going. Let's take a look at our other. All right, so that's PoE S0 is baked. Let's take that out of the oven. Okay. We're going to put S0 is going to be the one that's on the bottom. And we are going to, when this is done, I'm going to wait for this to be done because I'm going to take that network cable. And I can see that I've got cluster hat 00, P1, P2, P3, and P4 are all online, up and running. Everything looks good as far as the network is considered. I also have another machine back in a closet that I need to re-image. It's running Ubuntu right now. I think it's got a CD drive in it. So we'll go and rebuild that. And maybe that one I should make part of like a mixed cluster. Remember, I just found those. Let's make a mixed cluster. Oh, we'll call it Arkansas. Arkansas. And that one's the mixed one. Mixed architecture. I know that I can do this with K3S. It's like a HP x86 and Raspberry Pi 4. So that'll be able to take, I'll make the x86, I'll make that the control node And then these will be worker nodes. So it can take both types, ARM64 and x86. All right, so S1, I got to wait for this to finish so I'm going to restart this cluster. I'm just going to reboot that cluster, cluster hat 00. I'm going to reboot it, but I'm going to move it so I can get its network cable to deal with this PoE cluster that we're building next. So I'm going to do another, let's cook S1 while that's happening. All right, so we'll choose storage. This SD card is write protected. That's funny. I didn't know these little guys had. They don't. So that was interesting. Let's try this one. Same thing. Interesting. Well, good thing I've got other disks available. If this one shows up that way, then we did something wrong. All right. So this is going to be S1. That's writing. All right, this one's done. All right, so now on the cluster hat 00, all those nodes are done. So what I'm going to do now is sudo shut down now. Wait, that's P1. From here, I want to sudo shut down now. So I'm going to shut down that cluster. I'm going to move it into the closet. We'll start it back up, and then we'll go from there. We'll get our kubectl installed, or our Kubernetes installed on all 5 nodes, and then we'll move on. All right, so that's shut down. Let's take away its power. Let's move it back into the closet. And I will give Ethernet to the switch, and I'm going to plug S0 into the PoE switch. I see a green light, and I got power on S0. Hold on. Okay, this is not good. When I plugged in the other cluster, that cluster had 00 cluster, a blue light, an alert light turned on that I've never seen before. So I tried switching out the power and making some changes. It might be up there. I might have to pull it back out and just see. But I grabbed the same power adapter. It's connected to a different network. I couldn't have fried it just by moving it in there, right? Like I said, what could possibly go wrong? S2 is baked. Let's get S2 out of the oven and see if we can get that going. S2 or S1, sorry, S1 is plugged in, and S1 is getting power. So S0 and S1 are now going. And for those, we're going to kind of follow these steps, right? Do the update, install this stuff, and then go. So let's see if those come up. They are not showing up. Oh, wait, here. I see. It's clear. That's SSH to PoE. Oh, let's do to 10.99.1.61. Yep. All right, and then let's sudo apt update and sudo apt install Linux modules extra raspi -y and sudo apt dist upgrade. Do all the things. So that's PoE 00S0. Off to the races. Let's open up a new terminal. Let's do the same thing. If it ever, S1 ever comes online, I don't see it with an IP address yet. Looks like it's still coming up. I'm going to change some images. Identify my Raspberry Pis. S1 is a Raspberry Pi. Submit. Okay. Boop it. That's SSH to 10.99.1.101. Sure. And let's do the same thing. Sudo apt update. Sudo apt install Linux modules extra raspi and sudo apt dist upgrade -y. So that's S0 and S1 are being upgraded. While they're doing that, let's put S2 in the oven. This is such a lame stream. Like, I'm creating Kubernetes clusters. Like, I'm doing like data center, lamo, sysadmin stuff. Nothing cool whatsoever. And I wonder if like kids even do this. Like, is anybody even doing this anymore? Like with cloud and all that kind of stuff. I just don't have cloud money. I got Raspberry Pi money. I don't have cloud money. So this is S2. Everything else will be the same. Save it. I just want to double check here. This one. Write it. Yes. So S1. You know what I didn't do? I had it install on the SSDs. When I want to move the SSD on this cluster, I want to move it over to the NVMe drive so it goes a lot faster. So let's take a look and see. Raspberry Pi NVMe boot USB boot. To boot from NVMe drive, Raspberry Pi recent version of the bootloader are required. Okay, the NVMe drive can be connected to PC or Mac using USB adapter that supports blah blah blah. Reliability and speed, however, the Raspberry Pi itself may not be able to achieve its full potential with the NVMe drive. The fastest disk I/O speed on a native is 784, while the fast SSD. What? Oh, that's fine. It is possible to boot Pi CM4 from an NVMe drive by downloading the USB boot utility and updating the bootloader to include the option to boot from an NVMe drive. Upgrade. Let's see. Alex will know. You can upgrade the storage in Raspberry Pi 4 with an NVMe drive. These drives plug into a PCIe lane, which gives them a potential throughput. Yes, I can hear you shouting already for Hacker News, Twitter, Reddit. So before we get into the tutorial, let's start off with a disclaimer. The Raspberry Pi will not be able to achieve its full potential, but will have two advantages: reliability and sheer speed. Buying an NVMe and its associated adapter isn't much more expensive than SATA SSD, but is quicker and more useful if you need to repurpose it later on. The CM4 also has a PCIe lane, meaning you can connect NVMe to it. We will cover UAS and trim support in the addendum. Okay. If you have an external USB SSD or SATA M2, you can also follow this tutorial. So Raspberry Pi 4, power supply, SD card writer, USB NVMe adapter, NVMe drive with one notch, but it has two notches instead of one. It can achieve a slower maximum. Do I have one notch or two? I don't know. I think I just have one notch. We'll see. Whilst the Raspberry Pi cannot achieve full speed, it will perform to hundreds of megabytes per second instead of thousands. All right. Cool. Carefully insert NVMe drive in the caddy connected to your PC. See if it shows up as expected. So mine are just sticking out of there. How do I see if it shows up as expected? All right, so we'll check the bootloader version and do this stuff. But here's the thing. I'm using Ubuntu. I think these instructions are for Raspberry Pi OS. And he's using 32-bit? Oh, I know. Yeah. So different stuff. So we'll have to figure this out. We will figure this out. So not exactly the same instructions. There's the thing right there. Yeah, he always does this. I like that option. But I'm not doing he did Raspberry config here, but he doesn't have that in his instructions. It says this tutorial should also work for Ubuntu, but if you run into issues, try this tutorial found on Google. make Ubuntu boot from SSD on Raspberry Pi 4. Say goodbye to your SD card. Cool. Yes. Yes. Yeah. Sorry. Same-ish. Why do we need that? I'll bet you this was just to change the bootloader. Let's dive into it. Burn the Raspberry Pi OS. Burn Ubuntu. Wait. Oh, it says burn Ubuntu on the SSD directly. That was a smart idea. Boot your Raspberry Pi with the SD card for the moment. Don't plug in the USB disk. If you want to access Raspberry Pi from SSH, don't forget to add the SSH file. In my case, I'm accessing my Raspberry Pi by SSH. Don't forget to change them. Okay, so he did that. Or they did that. Then we're doing the same thing. I did dist upgrade. What's the difference between dist upgrade and full upgrade? This operation will upgrade the system and all the installed applications. Edit this and replace firmware release status by beta, which I don't think we need to do that. I wonder if that's even there. We'll see. Install the latest bootloader beta update by executing these commands. I think this is a once the rpi EEPROM update command finishes, reboot the Raspberry. After rebooting, you can verify the EEPROM has been updated successfully by executing this command and verify you have the last version. So he's using a July 31st. I don't think that bootloader, I don't think that's the beta anymore. I think it's been released for a while. Now plug in the SSD and mount its partitions. Let's find the name of the disk. And then now we'll copy the content of boot partition to mount boot. Man, this is not the way I would expect to have done it. But we'll figure it out. We'll figure it out. What could possibly go wrong? Well, I know one thing that could possibly go wrong. Cluster hat 00. Let's go check in on cluster hat 00. I'm gonna do this. Is 10.14.1.12. What? Now 14.1.112. It changed IP addresses. Oh, when I plugged it into the different, okay, 10.14.1.112. Sure. I would rather it landed on the right network. I gotta get it. I gotta figure out how to get it back to the network. I want it to be on the 1099 subnet, like it was, right? I didn't write it down, but I want it to be on the 1099 and not the 10.14. So what did I do wrong? It's because they come out of this switch. And I don't want to set up kubectl on 10.14, so I want to put it back on this network. All right, so I'm gonna do that. I'm gonna shut that down. I'll shut that down. We'll get this back. All right, cluster hat 0 is coming up. And S2 is baked. So let's take S2 out of the oven. And let's bring up S2. Repaving is what we're doing. We're repaving all the hardware. I don't think I need Raspberry Pi Imager at the moment. We're going to wait for cluster hat to come back up. Okay, cluster hat's back on 1099. So let's do this. Now it's on the 1099 network, as it should be. And what do we need to do? Let's just go make sure it's up. SSH to cluster hat 00. Yep. And then let's bring everybody up. So first of all, I didn't do this. I gotta do this before I do the install of K3s. So let's do that. Let's sudo nano. We're gonna have to boot this in /boot command line.txt, and we're going to add C group memory equals 1, C group enable equals memory. Okay, Control X, boop, boop. So that was for the control node. SSH to 10 dot. Did my others get IPs? Hello, cluster hat 0. Oh, they're not up. Haha. I gotta stand them up. So I gotta do cluster. I do cluster CTRL on P1, P2, P3, P4. So turn on those child nodes. Those green lights are coming on. All sorts of network stuff happening. We'll let those guys come up. There we go, cluster hat, P1, P2, P3, P4. There we go. Oh, wait. How come cluster hat 00 switched to 10.14? That's not good. What happened there? Well, let's, where did you go? They disappeared. What's happening? There we go. All right. So let's SSH to, let's do it this way. SSH config. I'm going to give these guys their IPs and their names. Boop, 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 boop. All right. So that's cluster at 00. This is P1 is at 70. P1 is at 70. P2 is at 71. P3 is at 72. And P4 confirmed is at 73. So let's SSH to cluster hat 00P1. Let's do this. SSH copy ID -I ID Sean at, no, I can just do cluster hat 00P1. Okay. And then I want to do sudo nano boot cmd. And this is so that I can do C group memory equals 1, C group enable equals memory. Done. I can do this. I can do sudo shut down R now. And then I can do copy to P2. And then SSH to P2. The same thing. Do the same thing with P3. CMD line. C group memory equals 1. C group enable memory. And last, do the same thing for 4. Oops. C group memory equals 1. C group enable. Did I do that right on all of them? We'll see. We'll find out. So I did that on all of them. So now all I need to do is cluster hat 00 to do shut down reboot. So the other 4 nodes, even though I rebooted the the control node, the other 4 nodes I think stayed on. So let's check that. I can't connect to them without it being on, but I think they powered on. So I think if I do something like this, if I go to P1, I'm going to let it boot up. I think if I go to P1 and I do uptime, it's going to be more than a few seconds. Yeah, good. So let's go to here. And I think we're ready to cook. So now I'm doing the same steps that I did on the single node K3S. So I'm going to follow these. I already have K3 SUP installed. So I'm going to do this. I'm going to do K3 SUP install. You know what though? I want to follow these instructions because I want to keep a copy of it. I want to keep my thing. So I'm going to do K3 SUP install --IP. This time the IP is 10.99.1.112. User is Deshaun. K3S extra args is -- disable traffic. And I want to, this is the part that I wanted to make sure. And C, Control V, and this is cluster hat 00. Put a little space over here. There we go. And it's working. Wonderful. Oh, look at this. Knative serving works with Courier works on a single Raspberry Pi 4 with HEB. So my single K3S node that we did, I wrote myself a note. I told myself already that it works. Man, sometimes those like note to self, those are super valuable. All right, so now I've got a kube config, and I go kube ctx, and I should see a cluster hat 00, and I do. Let's go. So now let's join. Let's do K3 SUP join -- IP 10.99. What did I say it was? 1.70 dash server dash IP is 10.99.1.1112 dash user Deshaun. Double check. I feel like that's good, right? I did 10.99.1.1112. All right, let's go. Oh, yeah, that's right. So I have, what we've done so far is we have one single node cluster that we can run Knative on, and now we've got this cluster hat cluster that it's not running Ubuntu, so we might run into some problems. But we can still run K3S on it. So we've got another type of cluster, and we'll go from there. Oh, wonderful. That all looks good, right? Excuse me. So we'll do the same thing for 71. Confirming. All right. So I'm going to move that over here. Yeah, just redo all the things. That was our dist upgrade for S0. Did I do the thing? So now I've got a bunch of these servers in flux. I gotta keep track. I don't think I'm doing a very good job of that. So 71 is going. Let's go over here. Let's do cat. Let's do cat. I don't think I did it over here. CMD line. Oh, it doesn't exist over here. So on Ubuntu, it's this one. And oh, maybe that was the difference. For Ubuntu, I had to do this step. I had to do the CPU set as well. We'll see. Sudo nano boot firmware cmd line.txt. And let's add C group enable equals CPU set. C group memory equals 1. C group enable equals memory. See, I don't know well enough to know if that's right or wrong. But we're going to do this. For S0 over there. Cool. We'll come back. I'm jumping around. It's probably like, that makes the stream even worse when I'm jumping around between all these different servers and configurations. So let's just do 72 and 73, and we'll get that cluster done. Then we'll come back over to the PoE cluster. So with this cluster hat cluster, it's going to be K3S. It'll be a 5-node cluster. We'll let everybody be a worker node, but it's got that one larger control plane node. It's running on SSDs, so it won't be super fast. So maybe we'll call it our dev cluster of some sort. And yeah, we'll see. Take some time. So let's figure out on the Ubuntu clusters. Let's figure out what they're doing. So S1 says, hey, do some stuff. We'll let S1 do its thing. So it did a dist upgrade. So we've done the dist upgrade for S0 and S1. So now I'm going to do the C group stuff for S1. Sudo nano /boot firmware command line. And we're going to add these things in front. Control C, Control V, space, done. Control X, boop, boop. Sudo shut down R now. So S1's coming back up. Fantastic. I'm going to close this just to keep my head on straight. So S0 is up and running. Everything that we need to do for S0 is done. So let's back out of S0. And we're going to come back to that cluster in a little bit. Notes are good. I'm actually even going to close those notes. And I'm going to come over here to our cluster hat 00. So that was 72. Now we're going to do 73. So now we've got two clusters for Kubernetes. Let's do this one. So we're joining all P1, P2, P3, P4. They're joined a cluster hat cluster. And I'm using K3sup to make it nice and easy. And then I have, whoops, I typed in the wrong, where did I type? I don't know where I typed. I typed somewhere. Let's do this, clear. And let's do kubectx, kubectx to show my clusters. I want to switch to my cluster hat 00. And I want to do kubectl get nodes -o wide. And let's take a look and see. Remember the whole goal as we're repaving, I just want Kubernetes dial tone, and I've got it. All right, so I've got my main control plane node, physical control plane node, which is also now it's set up as the control plane node for Kubernetes, and then the other 4 baby boards, those Raspberry Pi 02Ws, those are set up as worker nodes. Fantastic. We've got a recent-ish version of Kubernetes. And we can go back again, kubectx. We'll switch to the single K3s. Whoops, kubectx. And we'll run that same thing. And look, we're good. And this one just has one node. So yeah, we've been doing this for a little while, but that's okay. That is okay. So we've got 2 clusters. We have 2 clusters. That we've done tonight, cluster hat 00. So do we have time for one more? Let's go. They're running. You know what? The Kubernetes dial tone is great. Let's just be good with that. Let's get one more Kubernetes dial tone on this PoE cluster, and then we'll go. All right. So I got my notes taken care of. I'm going to even create a new terminal, a new window with basic. Okay. We're going to what did I say I want to do? I wanted to get off of the SSD and move over to the NVMe. Alex, where was that? Yeah, here's okay. He did this. Let's see if I can. Do I have this command? Let's go look at my SSH config again. Let's add these other machines. I got P's. This is PoE S0. And what's the PoE S0? PoE S0 is 1.61. S1 is 1.101. S2 is 1.207. So let's SSH to PoE 00 S1. Okay, we're up. Do we have no? Oh, I did it wrong. All right, so this version 2022-04-26, which I think that we're okay. It's no longer a beta. I think we're okay. So what that's telling me is sometime already before I made this available. So do I have this? Do I have Raspi config? No. So how do I change the boot order on Ubuntu? Let's see. Let's do this. Raspberry Pi Ubuntu boot order. Maybe I don't even need to do anything. I just have to copy everything over. So let's try this. Not this one. Let's try. So I don't remember how to do this, but so on a different machine or on the machine you used or another Raspberry Pi, attach the NVMe over USB and the SD card by the SD card writer. Use the NUC. And if I just do LSBLK, you should see your drive appear. Now the thing is, this is the SD card. SDA. That's the NVMe, right? Yeah, those are 128 gig NVMe drives. So here's the thing. He's doing dev SDB to dev SDC, but he's got the same number of partitions. So I don't. But you know what I wonder? I wonder if I just ran the RPi installer on the SSD drive, if I could just boot it without the SSD. If I install the Ubuntu OS right onto the NVMe drive, maybe it'll boot. Worth a try? I think so. I think it's worth a try. So let's do this. Let's go. Let's just do this one. What would I be missing? Let's just try it. Sudo shut down now. Okay. So you're off. You still have power. So that's S1. Let's do the same thing for S0. Sudo shut down now. Okay. And S0 shutting down. And what I'm going to do is I'm going to power off S0. I'm going to take out the disk. I'm going to go and we'll do the RPi imager again. But this time we're going to do RPi imager against this USB drive. So we're going to go, we're trying something new. It's all new, right? What could possibly go wrong? Wait, no. I want to do other general purpose OS, Ubuntu, 64-bit server here. Let's unplug you. So S0 is unplugged. Let's take S0 out. And let's plug S0 in over here. All right. So we have our NVMe drive. The disk you attached is not readable by this computer. Ignore. We're going to override it. Ubuntu server 2304. This is, it's going to be POE00S0. Enable SSH, do this. Let's give it a password. No LAN, do this, and let's go. Let's go. Yeah. All right. I don't see any, oh, I didn't do it. Okay, I see lights flashing on that NVMe drive. And let's just see if it boots. For some reason, I seem to recall that this latest boot loader is going to allow me to do this. Just boot off of USB. And I feel like I've done this before with this hardware, so I'm feeling pretty good. We can already see that this goes much faster on these NVMe drives than the SSDs. So what I'll need to do is take out the SSD card. I'm going to plug in the NVMe drive and we'll see if it boots up. Wow, that is night and day faster. Why haven't I done this before? Why didn't I do this? Why didn't I do this with all these cards? Because I can't. Actually, I can. I can on the cluster hat. I can put one of these NVMe over USBs. I can put one of those in, and I can make the child boards. I can have those mount partitions on the NVMe. But first things first, let's just get, all right, cool. So this is S0. We can take S0 out. We're going to plug S0 back in. And we're going to take the SSD card out. Got the SSD card out. And we are going to give it power. All right. Let's see what happens. Let's see what happens. Let's do it this way. Ping 10.99.1.61. I see it flashing. I think it is coming up. I see the disk flashing. Things are happening. I'd be really happy if this works. %, packet loss. The disk is flashing. We're trying. Oh, I got a solid blue. I think that's a good thing. Oh, nope, still timing out. So the disk, I'm just watching the disk. I don't know what's supposed to happen. I don't know if this is supposed to work or not. So I'm just watching that NVMe disk that we just installed. I'm watching it to see if it's doing anything. It's solid blue now. Flashing a little bit. Well, what I'm hoping for is that, hey, I'm going to get a route, and it's going to say, yeah, I got you. Oh, the IP changed. There it is. It's up and running. But the IP changed. .sh config. S0 is now at .62. So let's go do all the steps. Like, this is super awesome and exciting that was that easy, that it's not even an issue. So I'm doing all these steps again. Sudo apt update, sudo apt install Linux modules extra raspi -y, sudo apt full upgrade -y, because YOLO. Much faster. Much faster. Well, that's great news. So let's do the same thing. Let's boot down S1, shut down S1, grab the SSD card out, yank it, grab the NVMe drive. Let's bake it. Let's bake this. So I'm gonna power down S1. Powering down S1. Again, these are PoE drives, so I gotta unplug the network cable. I'm gonna yank the SSD card out. Boop. We booped it. We're grabbing the NVMe. We're gonna bake it. We're gonna bake this NVMe. Ignore. We're doing this on the NVMe drive, and this is S1. Everything else is the same. Bake it. S1. I'm going to power down S2. And I'm going to yank the SD card out of S2. I'm kind of excited about how, even though I went down the wrong path on a few of these things, I'm excited that it's now on the track that it's on. And I feel like we're making the progress. And this is the one that I said I was going to do microcates, right? And it's lightweight, fast, enterprise grade Kubernetes. All right, so this is what we're gonna do. I don't have desktop. I've got those. Got that. We're doing something similar. Okay. Build. Yeah, we've already done those things. Ours looks similar to that. Setting up each pie. Ubuntu server. Then we can SSH 2. Okay. Logging your pies to your network using RP. Okay, we're good. This is still updating. That said that was baked, right? I feel like there was a window that I missed. But we're gonna call it good. All right, you're going, so that's 0. S0 is going. We're gonna take S1 out of the oven. We already took the SD card out of S1, so I'm gonna plug in the NVMe drive back into S1. And I'm gonna give S1 power. I'm going to, I shut down S2. I took power out of S2. I took the SD card. So now let's bake the S2. Okay. So ignore, choose that. Let's rename it. The only thing that's changing here is instead of S1, it's S2. Everything else is going to stay the same. And right. Yes. Okay, now we're cooking. S2 is baking. S0 is updating. S1 is booting. Remember, that first boot took a little bit of time, and we got a new IP address. So let's see if S1 gets a new IP address. Doesn't look like it yet. Is it possible that S1 is already up? Because the S1 light is already solid blue. It's very possible that I didn't upgrade the bootloader on all of them the same way. So I could have to go back and update the bootloader on S1. Let's just give it a minute. We will open up a new terminal. And let's, S1 is not showing up. Wait. Oh, it's showing up as S2. That's weird. So here's S2 is baked. Let's see what we got. I don't know. This must be the time where I'm getting tired and starting to make mistakes. But we got 2 clusters up tonight, so that's great. I'm happy with that. We got Ubuntu booting from these NVMEs instead of from SSDs. So that's great. Now let's just see if we can get one more cluster, we'll call it good. If I can get one more cluster up tonight, I'll be happy. Standing up 3 Kubernetes clusters, that would be something. All right, so S2 is flashing. Talking about coming up. S1 or S0 is almost done updating. And S1 just looks like it's not doing anything. It's not showing up in my router. So that's not really good. S2 is still showing. It's doing stuff. It's got network traffic. S1 is not showing any network traffic at all. S2 looks like it's doing some work. S0 I can see is doing some work. So it looks like S2 got a new IP address. S2 is 207. S2 is still 207, okay. S2. Oh, it did get a new IP address. It just showed up as 208. But S1 has not shown up. Oh, wait, S1 has got some traffic now. How? All right. So S0, restart it all. It's all updated. We did the full upgrade, not just the dist upgrade. We did the full upgrade. I don't know what the difference is. You know what? Let's do this. Sudo apt dist upgrade just for walls. Yeah, full upgrade worked. Okay. The last thing here is this part, right? Sudo nano boot firmware. We want to add C group enable equals memory. C group memory equals 1. Now, this one is saying I didn't need to do the C group enable CPU set. So I need to go and update that. Let's call that good. And let's do this sudo shut down R now. So that's S0. S0 should be ready for Kubernetes, for K3S. Well, for micro-Ks. We're not doing K3S in this cluster. So that was S0. Let's do, what's S2 look like? We're going to do the same things that we did over here. Not that. That one's done for today. That's different work. Yep, that's done for today. We are doing this part. Sudo apt update and sudo apt install Linux modules extra Raspberry Y and sudo apt full upgrade -y. Go. So S2 is off to the races. Now we have to figure out why S1, sorry about that. We got to figure out why S1 is not showing up in the router. Is it just on the next page? Nope. All right, S1's not showing up in the router. S2 is. So my default assumption is that S1 didn't get the bootloader upgrades. So let's take a disk. We're going to install the latest Raspberry OS 64-bit just so that we can install the bootloader. So let's do that real quick. And this is a total guess, right? It's not coming up. I don't know why, but this is going to be our guess. We're going to boot Raspberry OS. We're going to boot Raspberry OS and make sure that it's got the right bootloader. So let's choose our OS, Raspberry OS. We want the 64-bit Lite. Choose this one, and it doesn't matter. We just want this. Right. Let's go. Power Pi. So let's write that SSD card for S1. Let's power S1 down. I shouldn't have to redo the USB drive unless it was a problem with the USB, right? But we'll see. We'll see. So the bootloader steps. I feel like I did the bootloader steps. Let's go here. do all the stuff. Oh yeah, I remember what I did. Oh, look at here, I did full upgrade instead of disk upgrade. Sudo rpi update. Upgrade the firmware. That's what I want to run. So we'll run the vc gen command to see what bootloader version it has now. And then we will run the RPI updater. And it's possible that the bootloader ends up being different on the different versions, which wouldn't be great, but hopefully it's not the end of the world. So let's grab this temp. Let's boot this guy, S1. We're booting S1 from SD card. And we're plugging S1 back in. And that'll show up as temp RPI. Now, the question is, will it try to boot off USB first or the SD card first? Looks like it's booting off the SD card first. Okay. Again, the SD card is slower boot, so we'll see. All right, I'm just looking at lights, waiting for this node to come up. So S2 is updating just fine. I can close RPI imager. I'm waiting for the temp RPI to show up at my router. And there it is. It's 102. All right, now we're going to do sudo rpi update. Oh, I didn't run the vc gen command D. It says, yeah. Right, it gives you that warning. This update bumps to rpi 61y. Linux tree cool RPI updates will be used. There is a specific reason it didn't boot. The only thing I really cared about is the firmware, which gives me the new bootloader. So let's go run this. This right here. Hey, I think that looks similar to the one that I saw before. So I'm feeling pretty good. But now I have this. I also have sudo raspi config, and I can update advance boot order, SD card, then USB boot, then boot. Yep. And I can also, remember while I'm here, I can do the performance options. GPU memory, I can change that down to 16. Okay. Finish. No, let's do this. Sudo shut down now. All right, so that shut down S1. I'm going to unplug S1 just to take away the power. I'm going to take out the disk from S1. I'm going to plug the power back in because these are PoE. And then hopefully this is going to boot off the USB NVMe drive. I have solid blue light. I still just have a solid blue light. This isn't looking good. This isn't looking good. Nothing. All right, well, that's not great. What did I do wrong? What should I do here? What could possibly be happening? So what I should do is I should plug this S1. I should plug this device into a monitor, and I should see what kind of diagnostics I'm getting. Not the best, not exciting. Let me see if I got a cool way of doing this. And I happen to have a pretty cool way of doing this. So I'm going to grab this, and I'm going to slide this one over here. And I'm going to shimmy this into here. And let's see if we can reboot S1. Oh boy. Hello, come on. Okay. S1 is down. S1 is coming back up, but I'm going to be able to see the monitor. What I've got to do is I've got to remove this camera, and I'm going to present another camera. Extra camera. Not the Okio, but the Camlink 4. And let's see what it says. Oh, so it's just trying to do the SD. So where did I put that disc? I took out the disc, but I don't know which one. Let's see. So let's try that again. Because when I did the bootloader, okay, so we're going to turn it off. We're going to put this one. I think this is. Let's see if it jumps back in. It said, nope, I don't like that. Let's get that extra camera. Let's see if we can bring that guy back in. Ugh. Doesn't likey. No likey. Let me try this. Present extra camera. Nope, it doesn't want to come back up. Is the okay? So temp RPI is up. All right, let's just go back to this one then. All right, so sorry about that. SSH to 10.99.1.102. And what we saw was that the bootloader was at the latest. Let me see what this is. So let's do sudo cat etc default rpi ee. So it says default, but I think that that's okay. rpi ee prom update. rpi ee prom update. rpi ee prom. What was that? I was just looking at rpi ee prom update. Oh, that was the name of the file. I think that's supposed to be okay. So the bootloader is controlled by the configuration file embedded in the EEPROM image and can be modified. Please see the bootloader configuration sections to view So I should just be able to do this rpi EEPROM update. So current is April. Yeah, this is the latest. Yeah, I want the latest. Sudo rpi EEPROM update. It says update available. -A. Reboot. Sudo shut down R now. Okay, let's just wait for it to come back up. Just thinking about it. But it's also doing the new bootloader update. I'm just watching flashy lights. All right. On the latest. All right, sudo raspi config advanced bootloader. No, advanced boot order. I don't know what was set. Okay. Finish. No. Shut down now. Okay. Let's try this again. Power off. S1. Take out the SSD card. Power back up with the NVMe. The NVMe is not flashing. Doesn't look like anything is working. What did I do? How did I mess up this guy? I updated the EEPROM to the latest. I said so I'm missing something, but that's okay. That's good. I gave it a valiant effort. I could do the 2-node microcates and add another node later. Let's go take a look. Maybe that's worth it. I would just wish I knew what I was doing. All right. All right, we'll come back to that. So we did this. Oh, this guy's got a that's S2. I've got to do this part for S2. C group. Enable memory. C group. Memory equals 1. Sudo shut down now. All right, same as sudo reboot. Oh, now I got to do now we can install the microcates snap. Sudo snap install microcates classic. It'll do that thing. What Kubernetes version is installing? Microcates is snap, and as such, it will automatically update it to newer releases of the package, which is following closely upstream Kubernetes releases. To follow specific Kubernetes upstream, it's possible to select a channel, for example. So channels are made up of a track based on microcates release. For more information, okay, discovering. Before going further, here's a quick introduction. Start, inspect, stop. You can easily enable Kubernetes add-ons to enable QDNS, enable DNS. To get further status of the cluster, okay. Master node and leaf nodes. So now that you have microcates installed on all boards, pick one to be the master node of the cluster. On the chosen one, run the following. Add node. The command will generate a connection string of the form master port token. Adding a node. Now you need to run the join command from another Pi. You want to, okay, so this is where we want to do our docs. So here, POE, we're doing on S1, we're going to do sudo micro case add node. That's on the main. This is on S0. Then on S2, we're going to do probably, right? Sudo micro case join. And you do this on all nodes, right? All right, so let's go here. SSH POE 00 S0. Okay, it's all updated and good. Now let's do sudo snap install micro cates classic. Let's try it without the classic and see what happens. Revision using classic. Okay, classic. From stable. And I tried it without the classic because like 1.17 is an old version. So I was like, this doc is really old. Let's see. It's past my bedtime. I'm feeling pretty good still. All right, so that worked. So now I should be able to do snap info micro cates. Okay. So can I get a regular kubectl? Micro cates kubectl cluster info. Sudo. All right, control plane is running. Core DNS, but I still don't have like the get nodes. So, oh, it's an even newer version, 1.27.2. That's exciting, but is it an older version of Containerd? It is. So newer version of Kubernetes, but older version of Containerd. I don't know what to say. I don't know what to say. But let's go here. Let's do this. Add node. It says, from the node you wish to join to the cluster, run the following. use the worker flag to join a node as a worker not running the control plane. If you are adding is not reachable through the default interface, you can use one of the following. What? If the node you are adding is not reachable through the default interface, that looks the exact same. But let's just do this. Copy. New window. SSH POE00S2. And we have to install the snap. I do this part first. What's up? What? Get scared? You want to hang out? Okay. Hey, just give me a sec. We'll hang out. All right. I'm going to call it good. I'll install this snap. I'll join it, and then we'll be done. How about there? We'll go watch a movie. So this command didn't do anything. It just told me the command to run on the worker node. Sudo. All right, gonna contact the node has joined the cluster and will appear in the node list in a few seconds. This worker node gets automatically configured with the API server endpoints. If the API servers are behind a load balancer, please set refresh interval and replace the API server endpoints with the one provided by the load balancer. So all I need to do is down here, I can go and say get nodes, and now I've got 2 nodes. Okay, so now what I'd like to do is get this kubectl merged into my other contexts. So I did this. Cool. For each new node, got it. Removing nodes. Okay. You can leave the cluster from a leaf. Okay, but how do I get my kubectl? I'll figure that out later. I've got 3 clusters. I was hoping to get 5 up by the weekend. I've got 3 of them. I'm feeling pretty good. Thanks. Yeah, we'll be doing more this weekend.